geobyte.
Dear students, now let us discuss the previous year questions for the very easy and important unit, that is work, power and energy. Okay, from this very easy unit, two questions can be expected for the exam NEET. That is the weightage of this particular unit for the exam NEET. That means it is high weightage unit. Okay. Now let us take the very first question. Look at the very first question asking like this. An object moving along the horizontal x direction with kinetic energy 10 joules is displaced through x equal to 3 I cap meters by the force minus 2 I cap plus 3 j cap, which is in newtons. The kinetic energy of the object at the end of the displacement is, what is the kinetic energy of the object? Means final kinetic energy of the object. Okay, that is the question. For that, let me write the given data. Initial kinetic energy, let that is Ki, given 10 joules. The displacement x equal to 3 I cap. It can be also written as delta x, that is the displacement 3 I cap, which is in meters. And the force acts on the object. The force acts on the object is equal to minus 2 I cap plus 3 j cap. The final kinetic energy Kf equal to how much? That is the question. As you know, according to work energy theorem, work energy theorem, work done by all forces must be equal to change in kinetic energy. It means final kinetic energy minus initial kinetic energy is equal to work done equal to F bar dot displacement delta x bar. Final kinetic energy minus initial kinetic energy given 10 joules is equal to force given is minus 2 I cap plus 3 j cap dot delta x bar is 3 I cap. Multiply only I to I. So final kinetic energy minus 10 equal to minus 6. Therefore, final kinetic energy minus 6 means minus 2 into 3. Therefore, final kinetic energy equal to minus 6 plus 10 is equal to 4 joules. That is the final kinetic energy. Look at the option C. Option C is absolutely correct. Understood clearly? It is very easy problem. Okay. Similarly, let us take the another important problem asking like this. An object falls from a height 10 meters above the ground. That means height of fall of the object from the ground is 10 meters. After striking the ground, it loses 50% of its kinetic energy. So initial kinetic energy equal to m into g into h1. That means initially the body is maintaining potential energy. That potential energy is converted to kinetic energy. By the time it is hitting the ground, it is hitting the ground, 50% of kinetic energy is lost. That means final kinetic energy equal to initial kinetic energy minus 50% of the initial kinetic energy, that is equal to zero point 0.5 times the initial kinetic energy. It is equal to zero point 0.5 times the initial kinetic energy is what? M into G into H1. Then the height up to which the object can rebounds from the ground. What is the right rebouncing height? That's what he is asking. Here we got K2 equal to zero point 0.5 times the mg h1. But K2 I can write m into g into h2 equal to zero point 0.5 times the mg h1. This mg part is cancelled. Then h2 equal to 0.5 I can write as 1 by 2. H1 is given 10. 10 by 2 is 5 meters. Therefore, rebouncing height is, the expecting rebouncing height is 5 meters. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. At any instant of time, the displacement of any particle is given by the displacement, let it be x, 2t minus 1, that is the displacement which is in meters. Under the influence of force acting on the object or particle is 5 newtons. The value of its instantaneous power. As you know, instantaneous power P equal to force multiplied by the velocity. Okay. Here the velocity equal to what? Velocity equal to what? Dx by dt. It is equal to d by dt. It is equal to d by dt 2t minus 1. Therefore, velocity equal to 2. It is in meter per second. Therefore, power P equal to what? Force 5 newtons multiplied by 2 equal to 10 joule per second or watt. Dear friends, remember 1 joule per second equal to 1 joule per second equal to 1 watt. 1 watt. Let me write it clear. 1 joule per second equal to 1 watt. Understood clearly? Anyhow, answer is 10 joules per second or 10 watts. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A particle moves with a velocity 5 I cap minus 3 j cap plus 6 k cap, which is in meters per second, horizontally under the action of a constant force 10 I cap plus 10 j cap plus 20 k cap newtons. The instantaneous power supplied to the particle. What is the instantaneous power supplied to the particle? This problem is very similar to the previous problem. Okay, it is given that velocity v bar given 5 I cap minus 3 j cap plus 6 k cap. Similarly, force is given. The constant force acts on the particle is 10 I cap plus 10 j cap plus 20 k cap. Okay, here velocity is in meter per second and force is in newtons. Then what is the instantaneous power? Instantaneous power, instantaneous power P equal to force multiplied by the velocity. Force is 10 I cap plus 10 j cap plus 20 k cap multiplied by velocity 5 I cap 5 I cap minus 3 j cap plus 6 k cap 6 k cap. You simplify it, multiply I to I, j to j like this. I to I, 10 into 5, 50. 10 into 5, 50 plus 10 into minus 3, 10 into minus 3 plus 20 into 6, 20 into 6. It is 50 minus 30 plus 120. It is 170 minus 30 is equal to 140 watt. Joules per second or watts. 140. Look at the option B. Option B is absolutely correct. Okay, na? Simple problem. Similarly, let us take the another important problem asking like this. The potential energy of a long spring when stretched by 2 centimeters is U. For 2 centimeter stretching, for 2 centimeter stretching in spring, the potential energy U, right? Potential energy is potential energy. Potential energy. Let me write it clearly. Potential energy. Otherwise, potential energy equal to U. Now, if the spring is stretched by 8 centimeters, what is the potential energy stored? If spring stretching distance, spring stretching distance is 8 centimeters, what is the new potential energy U dash? As you know, U equal to half into K into X square, U equal to half into K into initial stretching distance is 2 centimeters, 2 square. The final potential energy U dash equal to half into K into final displacement is 8 square. Then, then U dash by U dash by U equal to half into K into 8 squared by half into K into 2 square. Half K is cancelled. U dash by U equal to 8 squared by 2 square. 64 by 4 is equal to 16. Therefore, U dash equal to 16 times the U. That is the final potential energy stored in the spring. 16 times the U. Option A is absolutely correct. Look at the option A. Option A is absolutely correct. Okay? Na?
Geobyte.